So when we look at this next problem, it can seem really overwhelming when you're reading it because it doesn't tell you the real chemistry. It just gives you a lot of information. It tells you that you have calcium chloride and magnesium chloride mixed up somewhere. You've got it mixed together in a mixture. And this mixture has a mass of 2 grams. Then I dissolved this in water to make them aqueous, and I added sulfuric acid. The sulfuric acid was added until all the calcium was precipitated as calcium sulfate. That calcium sulfate was collected and dried, and it had this mass. What's the percent by mass of calcium chloride in the original sample? So this is a lot of information, and as a beginner, it seems like some information is missing. In my morning class, the first question was, wait a minute, what happened to the magnesium? Who cares? The magnesium chloride didn't do anything, so the magnesium is still dissolved in water. Okay, so the first thing you have to do is really understand the chemistry. But without that, let's just look at this from a practical point of view with my idea of going backwards. What do we want? We want percent of calcium chloride. How do we calculate percent? How do we find the percent of calcium chloride in a sample mixture? How do we find percent? The part divided by the whole times 100. So, to find the percent, I need grams of calcium chloride divided by my 2 grams of sample times 100, right? So this is where the 2 grams come in. Grams, the part, divided by the whole. Now, I know the grams of sample, but I don't know the grams of calcium chloride. So we look at the information and say, well, how do I get that? Well, what do we know? Not a lot, apparently. We know how much calcium sulfate we have, right? So is there a way that I can use grams of calcium sulfate to give me grams of calcium chloride? Haven't we done this over and over in Chapter 3? Took grams of one thing and changed it to grams of something else? Sure. What do I need to do that? Molar masses and a mole-to-mole ratio, and that mole-to-mole ratio comes from the balanced equation. So let's start with our balanced equation. So we start with the balanced equation. Calcium chloride aqueous. It's aqueous because it was dissolved in water. Plus sulfuric acid aqueous gives me calcium sulfate solid plus 2HCl aqueous. So there's my balanced equation. So now, looking at my balanced equation, calcium chloride to calcium sulfate is a 1-to-1 ratio. 1 mole of calcium chloride gives me 1 mole of calcium sulfate. So now this becomes the same old problems that we did in Chapter 3. I want my answer in grams of calcium chloride so that I can figure out what the percentage is. So here you can start with what you want or start with what you're given. So in this example, I said I'll start with what I'm given. 0.736 grams of calcium sulfate. So we change grams to moles, moles to moles, moles to grams. And if you like to start with what you want, we would have started with the molar mass of our calcium chloride. So 1 mole of calcium sulfate is 136.136 grams of calcium sulfate. Then, my mole-to-mole ratio. 1 mole of calcium chloride produces 1 mole of calcium sulfate. Now I'll change my moles to grams. 110.98 grams of calcium chloride, CaCl2, is 1 mole of CaCl2. So my grams of calcium sulfate cancel, my moles, and I get 0.600 grams of calcium chloride. For those of you that like to go backwards, you would have started with 110 grams of calcium chloride per mole, then canceled the moles with the mole-to-mole ratio, canceled the moles of calcium sulfate with the molar mass, and then put the mass in there. Now I have 0.6 grams. So my percent calcium chloride is equal to 0.6 grams divided by 2.0 grams times 100 is 30.0%. So when you look at it that way, is this problem any different than problems we have done previously? No. Haven't we calculated percent before? Yes, several times. Haven't we calculated how many grams of this does it take to make this many grams of something else? So this may look a little different because it's more wordy, but it is exactly the same kind of problem. So now the next one is for you to try. And again, it sounds wordy, but try and read it carefully. Think about where am I trying to go and what information do I need to get there. Do this with your group.